Hey, hello students. How are you today? I hope you're having a great Thursday evening. Let's get into our lesson. Today is part 2 of a 4-part lesson. This is all about transformations. Part 1 was about translations, and if you haven't watched those lessons yet, I strongly recommend going back and looking at them. But the next one, after you understand and you've mastered translations, it's to master reflections. And reflections are easiest explained if we use the square root family. So part 1 of today's lesson is actually the square root parent function. And by square root parent function, I mean y equals the square root of x. Now, square root of 0 is 0. So that is one of our key points, 0, 0. And then 1, 1 is actually also another key point, because if you plug 1 into this equation, out pops 1. But 2, if I plugged in 2 into the equation, if I made my little table of values here, 0 was 0, 1 was 1. 2 is the square root of 2. And I don't like having square roots on my parent function. I want nice, happy numbers on my parent function. Well, 3 has a value of square root 3. That's not particularly helpful. But 4, the square root of 4 is 2. So I'm actually going to have the point 4, 2 be my third point. And if you're noticing right now that, hey, these points look very similar to the points that we had for the quadratic, but they're opposite. That's true, and it's because x squared and square root x are inverses of each other. But that's a topic for another day. We're going to learn about inverses some other day. Today, we're just focusing on parent functions, the square root parent function, and reflections. So anyway, your square root graph looks basically like this, heading in an upward and outward direction. Okay, now part 2, let's get into reflections. And you're going to want some graph paper, so if you're not working on graph paper, maybe pause the video, go find some, come on back, hit play, and get caught up. We're going to examine 3 different types of reflections. Now, at the beginning, let's suppose that f of x equals square root x, our parent graph, because I'm going to test these reflections out using the square root graph. So for number 1, leave a little blank space here, because this blank space is where we're going to identify what type of reflection it is. But suppose that we were going to graph g of x, and g of x is like f of x, except there's a negative out front. Well, if I put a negative in front of this f of x, the negative would also have to be in front of square root x. So number 1 is, suppose that g of x equals negative square root x, or negative f of x. For number 2, we're going to put that negative on the inside. So suppose that we had h of x equals f of negative x, which is the square root of negative x. So let's graph these two, see what's going on with them, what kind of reflections those give us. And this is where the graph paper is going to come into play. So number 1, I'm going to graph g of x equals negative root x. And for number 2, I'm going to graph h of x, which is square root negative x. All right, here we go. I'm going to move up here for a little while. All right, easy. When we started graphing functions, we start off by a table of values, x, y, and we'd use the exact same values. 0, negative square root of 0, that's just 0. 1, negative square root of 1, well, that's just negative 1. 2, negative square root of 2, well, that'd just be negative square root 2. 3, negative square root 3. But that other point of importance from earlier, 4, negative square root of 4 is essentially negative 2. So if I graphed this graph using these 3 points that were kind of my points of importance from earlier, I have 0, 0, 1, negative 1, and 4, negative 2. And then I connect the dots. All right, that's the first one. Before I go back to the note, to this part of my notes, I just want to go ahead and do my second graph too. Now, 0, still the same. Square root of negative 0 is the square root of 0, which is 0. Problem turns up if I try to do 1. If I plug 1 into this equation, the square root of negative 1, we can't do the square root of negative number, so we're stuck. Or are we? We're not stuck. You just need to think of, well, what numbers would allow me to actually take the square root of this number? And that would be negatives. The square root of negative 1 is simply the square root of 1, which is equal to 1. Negative 2. The square root of negative 2 becomes the square root of 2, which is just square root 2. Negative 3, square root 3, and then negative 4 is square root of 4, which is 2. So on that graph, put this graph right here, I had 0, 0, and then I'm going to use negative 1, 1 as a key point, and negative 4, 2 as a key point. Okay, so if we bring this back to what we said originally, this first graph was the square root negative x. So when the negative is in front on the outside of the function, that is giving us a, if you compare our original parent function and this graph, this is a reflection over this horizontal line, the x-axis. So square root of negative x is an x-axis reflection. And then number 2, this square root of negative x, that worked out to be this graph. And if we compare that graph to our original parent function, there we go. This one's the original. This is the transformation. This graph has been reflected over the y-axis. So 2 is a y-axis reflection. And then, well, what about a double? What if we had a third one? We'll call this one m of x. And what if there's a negative out front of the function and a negative on the inside? So that would be like negative square root negative x. Well, if you're thinking double transformation, you're right. Let's take a look at this Desmos graph I prepared earlier. Here we go. So I originally printed square root x, and that was my original graph. And then the blue one was the second one I did, which was negative square root x, which, which technology confirms what we did on the graph paper. This green one, negative square root negative x, is this third, is this green one, just like our work showed. And then negative square root negative x, that's the double. So it reflected over the x-axis over here, then it reflected over across the y-axis over here, and we end up with a graph like this. So going back to our work that we were just doing in the paper, let's make this small. Let's make it really small. Number 3 represents an x-axis and a y-axis reflection. Okay, and then just to formalize what we've come up with here, let's look at this transformations definitions paper that I put together. This is a list of our transformations so far. When we had this thing that was inside the function, we talked about doing the opposite of what it says, and that's why there's this minus here. But this would be a horizontal translation of h units, and then plus k here, so a vertical translation of k units. Well, if we look back to what we did, our x-axis reflection was this negative in front of the f of x. I'd say outside the function. So whether this function is positive or negative in front, that determines whether it's going to be a reflection. So I'm just going to put this positive negative and mention down here that negative is a x-axis reflection. And our y-axis reflection was when the negative was on the inside of the function, affecting the x-coordinates. So inside the function, I want the x to be negative, but I still need to maintain this x minus h. So within these parentheses, I actually make a smaller set of parentheses, and I'm going to put a positive negative here. And then in this case, a negative is a y-axis and y-axis. That doesn't sound right either. Reflection. Okay, and students, that is the theory behind reflections and our parent function. So that's just part one of today's lesson, just the theory behind reflections. Part two of the lesson was going to focus on examples. How would we apply these reflections to our practice? So I'll see you in a couple minutes with part two.